Hello everyone, welcome to the demo of my streaming chart interface with LLM Tool Visualization. The goal of this project is to solve a major UX problem into modern AI apps. When an LLM uses tools, the user is usually left staring at a blank loading screen. I wanted to build a premium glassmorphic UI that actively visualizes the server-side tools the LLM is using in real time. This is the UI. My architecture uses a React frontend managed by White and Justin. It connects via servers and events SSC to a Node.js Express backend running in Docker. To power the intelligence, I'm using the Groq API connected to the massive Llama 3.370 billion versatile model for lightning fast tool reasoning. These are the code. This is Docker file. This is the front end and this is the back end. Now I'm switching to the UI. This is the UI we have. Now I'm started demo. Now first we all check the calculator. What is 453 times 89? The calculator, the LLM return the value. The result of 453 times 89 is 40317. Let's test our backend tool. I ask it to multiply 450. Now how the UI instantly pops up a tool execution block before the text generates. Behind the scenes, the LLM realized it needed a calculator. It parsed the stream, sent a function callback to our node backend. The backend evaluated the math using math.js in just 4 milliseconds. Then recursively fed the answer back to the LLM to stream the final result. Now I am switching to the code editor. The charger.js. While streaming, if we quickly look at the backend code in the charger, you can see how this is achieved. Instead of standard REST API calls, I implemented a robot server sent event streaming pipeline. When the LLM decides to use a tool, my code intercepts the stream, processes the JSON tool arguments, executes the local JavaScript function like calculator, formats the results exactly how OpenAI or Groq or Gemini expects it, and then looks back around to make a second API call seamlessly. The front end receives distinct text delta and tool call start events, allowing it to render those beautiful isolated UI blocks. Now I'm switching back to the browser. I'm asking the time. What is the exact time in Tokyo now? The exact time in Tokyo now is 1:32 seconds AM and GMT plus 9 and 6:27. The LLM triggers the current time tool. Our backend dynamically grabs the server's time, securely formats it for the Asia or Tokyo time zone using JavaScript enter date, time, format, and time returns its proofs. Our backend can handle complex formatted parsing like time zones from the LLM directly into our internal functions. Now I'm checking the knowledge base. Like, when was our company founded? It written. Now, for the most complex tool, the knowledge base, I ask a proprietary question: when was our company found? This is not a simple keyword search. When this is called tool or node backend actually runs a lightweight AI embedding model, all mini LM L6V2, entirely local inside our Docker container like ONNX Runtime. It converts my text prompt into a mathematical vector, compares it against our internal vector database using cosine similarity, extract highest matching fact, which is 2015, and the LLM relays it to the user. This allows the LLM to securely read our internal company data without us having to upload our entire database to Groq. Now switching back to the VS Code, to make this local embedding model work from Node 18. I had to overcome a major infrastructure hurdle. Originally, the backend was running on Alpine Linux. However, Alpine uses music libc, which caused the ONNX runtime engine to instantly crash. I debugged the dynamic linking error and rewrote the Docker file to use a Debian-based image 18 bull I slim, which natively include the standard libc. Now I'm switching back to the browser. The no tokens is 190. Fine, let's talk about the memory management. As we have been charting, our context monitor on the left has been tracking our exact token uses in real time. I integrated the exact token library back into the guarantee byte perfect counting. Because LLM have a finite context window, long conversation will eventually break the app. To solve this, I built a summarize and compress feature. Was the token count when I click the summarize and compress feature? It reduces to 94, and it gives us compressed and summarized answer like 453 times 89 equals to 43 on the exact time in, like the company was from 2015, and no decision was made, no specific names were mentioned in the conversation. Factual summary of the company and completely other overrides our front end state. Our token count just dropped dramatically, freeing up our context window while preserving all the historical facts, was which we discussed in the conversation. That is the complete architecture of the streaming chat interface. Thank you for watching my video.